the part B, or the third experiment you're going to run for the torque and second condition of equilibrium lab. We have our meter stick with a spring scale clamped at 20 centimeters and 70 centimeters. And off the spring scale, you can actually read the upward force that these two supporting forces need to create. You can also see 3 weight hangers with given weights added to them. And if you follow the instructions in the lab, they ask you to place an approximate amount at 10 centimeters, at 40 centimeters, and at 95 centimeters. I went ahead and changed the values a little bit because I want you to do your own work, and I moved all of these weight hangers back and forth a little bit until I found that the meter stick sat horizontally. If I moved this rightward one out too far, everything would sag and you'd get a rightward lean, etc. So equilibrium is when they are approximately, the meter stick is approximately horizontal. Record the mass of all your weight hangers and the clamps holding the weight hangers on there. You can ignore the mass of these clamps holding the spring scales because the spring scales themselves have taken into account the mass of that clamp. So find your equilibrium situation and record all known values of masses and positions. And then you'll have to calculate torques about certain points. So make sure you have all the data before you go ahead and start.